Interest, simple and compound. Let's start with simple interest. Simple interest uses the formula I equals PRT. So to find interest, or I, we take the principal, that's the amount of money invested or borrowed, multiplied by the rate, or the R, is an annual interest rate converted to a decimal. And T in I equals PRT is for time, and time needs to be in years. So let's take that formula, I equals PRT, and you guys pause the video here and find the simple interest using the formula I equals PRT for these 5 questions. All right, welcome back. So if I use I equals PRT, $1,000 at 5% for 2 years, the amount of interest would be $100. Your balance would be the $1,000 plus $100, but your amount of interest would be $100. Number 2, $64.80 in interest. 3, $225 in interest. 4, $352.80 in interest. And number 5, $324. Now, all these were in whole years. We had 2, 3, 2, 4, 5. What if we had part of a year? What if we had, what would you do if you have less than a year? So we could think of things out of months. So let's say 9 months would be, we couldn't use 9 because 9 would be 9 years. We could take 9 divided by 12 and put 0.75 in for time. Or if you had 6 months, that would be 6 twelfths or 0.5 for time. So in simple interest, you do need to be careful and make sure you put in your percent as a decimal. Make sure you put your time in years. But simple interest, pretty easy formula to use. Now, compound is a little bit more complicated, and compound interest is when the bank or any type of corporation pays, or an individual pays interest on both the principal and the interest on the account has already earned. The bank is paying compound interest. An interest period is the length of time over which interest is calculated. So simple interest, we get the interest at the end of the time period. Compound interest is going to pay interest on top of interest on top of interest, which makes it grow exponentially. So we have this formula. You want to write this down. Pause the video here. This is a very important slide. We have A, the amount, which would be like the balance of our account. P would be the principal. That's the amount of money that we start with, that we borrowed or we're saving. R is the interest rate as a decimal. N will be the number of times the interest is compounded per year. So we could have annually once a year, we could have semi-annually twice a year, we could have biannually twice a year, we could have monthly 12 times a year, and then our time in number of years would be T. So hopefully you have that all written down, and let's move forward with some examples. So suppose your parents deposit $1,500 in an account, paying 6.5% interest compounded annually, which is once a year. When you're born, find the account balance after 18 years. All right, so we got to figure out our principal, which is our amount of money, our rate, which is an annual percentage rate, also called APR, and banks always advertise in APR. They don't say how much per 6 months, how much for 3 months. Banks always put things out, and investment corporations put things out based on annual rates. So APR, or annual rate. And then N would be the number of times paid per year and time. So we substitute into our formula. We're going to put in $1,500 for the principal, 6 at 0.5% as a decimal, 0.065. And how many times are we paid that? Once per year. And we want to know after 18 years. So we have a divide by 1, which is just the original. We have a multiply by 1, which is just the original. So we have 1 plus 0.065. 1 times 18 is 18. Now, calculator is going to be super handy for this because you can put in 1.065 to the 18th power equals times 1,500. And you'll get that you would have $4,659.98 after 18 years. All right, now let's look at that same problem, the same numbers, and instead of doing annual, suppose we have that previous example, but now it's compounded quarterly. So it's compounded 4 times a year. Well, they're not going to pay that same percent 4 times a year. They're going to divide that up. So our n is going to change. The number of times it's paid. So the rate of 0.065 is divided by 4. And then our exponent, that 18 times, it's paid 4 times per year for 18 years. So the percent is divided by 4, but the number of times it happens, or the frequency cycles, is multiplied by 4. So then we get 1.01625 to the 72nd power. And we put that in our calculator, 1.01625 to the 72nd power times 1,500. And we would get $4,787.75. So would you make more money if it was compounded 4 times a year than once a year? Yes, because you're paying interest on top of interest on top of interest more often. So the more times it happens, even at that same rate, but 4 times a year, will still grow quicker because you're still getting paid interest on top of interest, which is the exponential growth part of compound interest, where simple interest was very linear. It was the same amount. So if we look at the compound periods, so let's say you have an annual interest rate of 8%. So an annual interest rate of 8%, if it's paid annually, that just means once it's 8% per year, every year. Semi-annually means they're paying twice a year, or they're paying every 6 months. While they advertised 8% APR, or annual percentage rate, annual interest rate, you would have to divide that by 2. They're going to pay 4% every 6 months to get that 8%. That's the R divided by N part. Quarterly, even if it's 8% APR, that means they're going to pay 2% every 3 months. So this annual rate would get divided by the number of times it occurs in a year. So monthly, we would take 8% and divide by 12. So this R over N part, to understand what's going on here, it's taking that annual interest rate or annual percentage rate and dividing it by how often it's compounded. All right, suppose your rich uncle gives you $20,000 when you graduate high school, and you wisely invest it in a bank that pays 3.5 APR, annual percentage rate, interest compounded monthly. How much money would you have after 10 years? All right, pause the video here, and we'll come back and see how you did. Try this one out. All right, so we have $20,000 for our principal. We have 0.035 as our percentage rate, as a decimal, divided by 12. See, this one is monthly. So notice how the blue numbers are 12. So we have 12 and over 10 years. So it's going to do 120 times. It's going to pay this small percentage rate, but it pays it so many times that you're having that exponential growth happen even quicker. So we can put in our calculator 0.035 divided by 12, and we get a big long decimal. I went out 6 places. That's going to get us pretty accurate. You can go out further if you want, but this is going to get us pretty close. And then 12 times 10 to the 120 power. So I put in my calculator 1.002916 to the 120th power times 20,000, and we would get $28,364.63. So taking that $20,000, sitting in that bank for 10 years, we get $8,364.63 in interest over that 10 years by just not touching that money, by letting it grow on its own. This one part of the formula, notice how the multiplying by 1 just includes our original amount to make sure that we don't just get the $8,364.63. This 1 makes sure we're including the amount we started with, which is true balance of the account, is we still have the $20,000 we started with. We just have this additional $8,364.63 in interest. So I hope that helps you guys get started. There is a big difference between simple interest and compound interest. Simple interest is linear. It grows in a straight line. And compound interest grows exponentially. Have a great day. OUT spells